Well, pre-calculus classes, good morning, good afternoon, or good evening. I realize now when you guys are watching these that may be quite a bit of varied times, but we are going to go ahead and get started into section 5.2, which utilize what are called the sum and difference trig formulas. And I know if you notice the very first thing up at the top of this page, we do no longer make you memorize these. It's probably been about 5 or 10 years since we last made the classes actually do that. Although you will see that even though it looks like there are 6 formulas, technically there are only 3 of them. But cosine of alpha minus beta, cosine alpha plus beta, these are Greek letters. If you want to use just A and B as you work through these, certainly feel free to make that minor change. But the cosine of alpha minus beta formula says cosine alpha, cosine beta, plus sine alpha, sine beta. Well, when we do the sum formula, you will notice there's only one minor change, and that is that instead of adding, we subtract the two expressions, cosine alpha, cosine beta, minus sine alpha, sine beta. For sine of alpha minus beta, that is sine alpha cosine beta minus cosine alpha sine beta. Sine of alpha plus beta, sine alpha cosine beta plus cosine alpha sine beta. So just like the first two, the only thing that changes as you work through these is the addition or subtraction sign in the middle switches. The last two formulas are for tangent. Tangent alpha minus beta is tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Well, the sum formula, much like the others, the only thing that changes are the arithmetic signs in between. So this is tangent alpha plus tangent beta. Your denominator is 1 minus tangent alpha tangent beta. Now, as far as how we actually use these 3 or 6 formulas, however you want to view it, is to help us find some of the spots on the unit circle that aren't actually labeled. I don't know if, as we've worked through things, if you had actually kind of wondered, okay, well, why don't we actually worry about the spot in between 0 and 30 at 15? Or in between 90 and 120 at 105, or even, I don't have it labeled, 60 and 90 at 75 degrees. Well, you'll see the reason we don't actually worry about those all the time. Now, what we have to do, in order to work with 105 degrees, you have to find 2 values on the circle that will either add or subtract to 105. I know when I see 105, the first thing that comes to my mind is I'm just going to add 60 and 45. It's not the only option. There are, really in theory, an infinite number of ways you could do this. If you wanted, you could even take 150 minus 45. So what I'm going to do, though, is set up the sine of 105 is the sine of 60 plus 45. And now these are my alpha and beta. Does not matter which one lists first. When you actually use the formula, that will take care of itself. So if you look up, sine of alpha plus beta, sine of 60, cosine 45. Then plus cosine 60 sine 45. And so this is the reason it does not matter which one you make alpha, which one you make beta. You use both sine and cosine of 60. You use both cosine and sine of 45. Now, I know it's been a good couple of weeks since you've possibly even worried about the unit circle. Now we're just going to use some exact values. Sine of 60, radical 3 over 2. Cosine of 45, I'm not going to actually go back to the circle for those. Cosine of 60, 1/2. Sine of 45 is radical 2 over 2. Now, as far as simplifying from here, radical 3 over 2 times radical 2 over 2. Radical 3 times radical 2 is radical 6 over 4 plus radical 2 over 4, which we cannot actually combine those, but we are going to at least condense that to a single fraction. And you can see this is the reason we do not expect you to memorize those values at places like 105 degrees. They're certainly not anywhere near as user-friendly as 1/2, radical 2 over 2, or radical 3 over 2s. But that is our first example. Well, moving on, now we're going to find the exact value of cosine pi over 12. When I have a radian value for these, I'll admit I actually like to convert to degrees. You don't have to. So that gets rid of our pi's. Now, if you don't want to try to reduce 180 over 12 in your head, just divide kind of both by 3, and you get 60 over 4, which is 15 degrees. So if you don't want to work with radians, just go ahead and use degrees. Kind of like the last example. Now what we're going to have to do, find 2 spots on the circle that equal 15. For this one, you're probably going to have to use a difference. Again, probably the easiest option, either 60 minus 45, 45 minus 30. You can use any combination you want. You know, even 135 minus 120 would work. I'm going to use 60 and 45, if nothing else, because it uses the same 2 from the last problem. So again, there's our alpha and our beta. And now what we're going to do, come in and use our formulas. So cosine 60, cosine 45, plus sine 60, sine 45. And now you just plug in your exact values. Cosine of 60, 1/2. Cosine of 45 is radical 2 over 2 plus sine of 60 is radical 3 over 2. And sine of 45, radical 2 over 2. Well, that becomes radical 2 over 4 plus radical 6 over 4, which if this looks familiar, it is the exact same answer as example 1. And the reason, if you think about it, example 2, cosine of 15, the x value at this spot matches the y value at 105. You know, you've just rotated 90 degrees, so the x value here and the y value there, because on example 1 we use sine, are equal. As you work through these sum and difference formulas, you're going to see a lot of combinations of radical 2, radical 6 over 4. The main thing that'll be different is whether or not you have positives or negatives in your numerators. All right, example 3 is a little different style of problem. Now we're going to actually kind of work backwards. Cosine 42, cosine 12, sine 42, sine 12. Think of it as here are our alpha and beta. And now what we're going to do is we're going to come back and find, okay, well, which of our 4 identities does this match? Well, cosine, cosine, sine, sine, so we're definitely using one of the 2 cosine formulas. And from there, it's going to be the one that has addition in the middle, so it's a cosine difference formula. So this becomes the cosine alpha minus beta. 42 minus 12 is the cosine of 30 degrees, which when you have something that is on your unit circle, once again, if you're kind of getting back into remembering that, Cosine of 30 is radical 3 over 2. All right, one final example for the first half of section 5.2, tangent 105. Now we're going to let you guys actually pull in the tangent formulas. And for 105, I'm going to just keep using the 60 and the 45. So tangent 105 is the same as 60 plus 45. Again, there is our alpha, there is our beta, and now we're just going to fill in using our formula. So tangent 60 plus tangent 45 all over 1 minus tangent 60 tangent 45. Well, if you remember back, certainly before spring break, one of the things we had you do was a unit circle quiz where we had you find all of the tangent values. You know, we do not expect you to memorize those, although I would say hopefully you would do at least know tangent of 45. If you don't have that handy, if you remember to find tangents, tangent is sine over cosine. So if I want using 60, again, you can just come in on your unit circle. The sine of 60 is radical 3 over 2. The cosine of 60 is 1/2. So the tangent of 60 is radical 3. So now as we come up to our formula and fill in, well, we have tangent of 60 is radical 3. Tangent of 45, because sine and cosine match, it is simply 1 over 1 minus tangent of 60 is radical 3. Tangent of 45 is 1. So now we have radical 3 plus 1 over 1 minus radical 3. Well, here is the bad news. We have a radical in our denominator. We do have to rationalize using the conjugate. Conjugate of 1 minus radical 3 is 1 plus radical 3. So as we work through that, we have radical 3. As we FOIL, 3, 1, and radical 3. For our denominator, we just have 1 minus 3. So to finish this up, what we end up with is 2 radical 3 plus 4. Our denominator is negative 2. And to finish, now we just divide the negative 2 into both of those. 2 divided by negative 2 gives us a negative radical 3. 4 divided by negative 2 is minus 2. So that finishes up 5.2 day 1. There are assignments on Pearson for this section.